Exercise 4 on lesson 26 is another rational equation that we're asked to solve. This time we're solving for A. We're looking for the values of A that make this equation true. And the first thing I'm going to notice is that this right-hand side, the denominator on the right-hand side, can be pretty easily factored. It is a difference of squares. And it factors like that. So I've just rewritten the right-hand side of this equation. And I notice that these factors appear on the left-hand side, one in each of my rational expressions on the left-hand side. So in order to find a common denominator, I need an a minus 2 as a factor on the bottom of this first one. So I can multiply the top and the bottom by a minus 2. And it looks like this. And the second rational expression on the left-hand side, I can multiply the top and the bottom by a plus 2. So that looks like this. Now, all three of the rational expressions that make up my equation have the same denominator. So on the left-hand side, I can go through with this addition now, a minus 2 plus a plus 2, and that's going to give me 2a on the top, and I have this denominator on the bottom, a plus 2 times a minus 2, and that equals 4 over a plus 2 times a minus 2. And just like I did in the last two problems on the front of this document, if I have two rational expressions that are equal and their denominators are equal, their numerators must also be equal. So I can just say 2a equals 4. And from here I can solve this equation for a equals 2. And that is the value of a that I came up with, the single value that I got from solving this equation. But before I put a box around it, I need to just confirm that value of a, in fact, makes my original equation true. And maybe you already noticed that if I put an a, right, a value of 2 in for a here, that causes this expression to be undefined. It would be 1 divided by 0, and dividing by 0 is undefined. On the right-hand side, if I put 2 in for a, I get 4 minus 4 on the bottom, and that's also 0. So 2 of the 3 rational expressions in the original equation are undefined when a equals 2. So this is actually what we call an extraneous solution. And I'm going to label that. This is an extraneous solution because it causes the original equation to be undefined. So what is the solution? Turns out that this thing has no solution. So the solution is no solution.